let's try to find the area between the graphs of these two functions, f of x, 5 to the power x, and g of x, 4x plus 1. So when I tried to solve this problem, the issue that I had is I tried to find the points of intersection. Because here, in general, if we have two functions and we want to find the area, we need to find the points that we can use as our bounds for the integral. Here, if we try to find these points, and if we try to get these 2 points, we have to solve 5 to the power x is 4x plus 1. So we need to solve this equation. And clearly here, the domain for the solution is going to be R. We have no restriction. Okay? If we try to solve this one, we don't have a specific way to solve this kind of problems, but we can study functions. We can define a function. F of x is 5 to the power x minus 4x minus 1, and we can study this function. Okay? We can use the intermediate value theorem, okay, and the mean value theorem. That would definitely help us finding this solution. Anyways, if we try to find points of intersection, I get 2 points. Clearly, we see that 0 is a solution. Okay, because 5 to the power 0 is 1, and here we have 4 times 0 plus 1, which is 1. Okay, 0 is a solution, and 1 is also a solution. Okay, so we have these 2 points of intersection. Okay, if we graph the functions carefully, we see here, this is an approximation. It's not exactly the graph. Okay, let's say this is 5x, 5 to the power x, and this is 4x plus 1. This is minus 1 over 4. Okay, here we see that the two solutions are 0 and 1. Okay, so here, so we want to integrate this area here. So the area is this part here that we want to find, and we have these 2 points 0 and 1 as the only solutions. So the issue now is to prove that 0 and 1 are the only solutions. Here, between 0 and 1, to prove that there is no other solution here, we use the mean value theorem. Okay, we apply it here, and here we use the same thing, and here we're going to use the mean value theorem between minus, let's say, any number less than 0 and 0. Okay, so the mean value theorem would definitely help us proving that this one, the 0 and 1, are the only solutions for this equation. Okay, so once we do that, we can find the area by just noting that since we are looking for the area, we are looking for this integral between 0 and 1 of 4x minus 1 minus 5 to the power x dx. Okay, and 4x plus 1, and this is, we know that this is 2x squared plus x minus 1 over ln of 5 to the power x between 0 and 1. Okay, so here if we evaluate this one, we're gonna get 0.5. I think this is the area, this area. The issue is finding these points 0 and 1 and proving that these are the only one. So to prove them, we use the intermediate value theorem and the mean value theorem. Okay, we're gonna do that in a separate video. So the area now is this integral here. Okay, so here between 0 and 1, these points of intersection, and 4x plus 1 is on top of 5 to the power x between 0 and 1. That's why we have this one minus this one, because we wanted A to be positive. Okay, that's why we have F minus G in absolute value as the area. But if F is on top of G, we get rid of the absolute value, and we have the area is just F of X minus G of X dx. And I think you know this formula here. Okay, and the issue here is 0, finding the point of intersection. Okay, and for me it's 0 and 1, and we're gonna prove in a separate video that these are the only solutions of this equation here, or the only points of intersection. Okay, 0, 0 and 1, 0. Okay, so it's good to work this problem. Try to see, what do you think? What's your solution? How can we solve this one? Okay, please leave that on the comment. Thank you very much.